Okie doke. This first part here is just going to be an introduction to titrations that you're hopefully watching first. It'll take just a couple minutes to go through a couple of details about them. A reminder that the word titration means that you are adding something stoichiometrically to something else. In this case, what you're adding is a strong acid or a strong base with the purpose of neutralizing whatever substance is in the beaker, right? So if you have some sort of acid in the beaker, then the thing that's going to go in the burette will be a strong base. If you have some sort of base in the beaker, then the thing that's going to go in the burette is going to be strong acid. Because the purpose of it is neutralization. Because through neutralization, you can find one of the key things we're looking for in a titration, which is the equivalence point. The point where the moles of H plus are equal to the moles of OH minus, and that happens stoichiometrically. Right? Generally, you're going to also, at the same time you do this, create a graph similar to what you did for buffering capacity. You're going to do pH versus volume added, and you're going to need to know some things about the graph that we'll talk about in a second. You'll either do this on the computer or you will use a lab quest to create a graph. You're going to do it past the equivalence point, actually. You're going to do it for the whole spectrum of the titration. At a reminder, we touched upon this briefly in the indicators lecture. There are three ways to find the equivalence point. Right? You can do it through stoich. You know you've hit the equivalence point when the moles of acid are equal to the moles of base, stoichiometrically. You can do it graphically, and what's going to happen eventually is instead of having acid, excess acid, if you're titrating an acid with a strong base, initially you're going to have a lot of acid, so the graph will remain pretty low in pH. And then all of a sudden, you're going to get a dramatic change where it begins to neutralize, and it's going to go up real fast to neutral, or the equivalence point pH, and then it's going to go beyond it when you have excess base. And if you take the midpoint of that vertical jump there, right, the midpoint is an estimated equivalence point pH. So that's nice. The other thing you're going to want to do, as a reminder, is to use an indicator. And what you want is the pKa of the indicator. You'll be given different indicators with their Kas. You want the pKa of the indicator to be similar to the pH at the equivalence point. So every time you do a titration, you're going to ask yourself, what is the pH at the equivalence point? And then you're going to select the correct indicator for the job, because it will then change color, giving you a nice visual end to your titration. There are going to be things that you're going to have to be able to explain and to calculate throughout the titration. You're going to have to explain why it starts initially where it starts, and initially what happens after a small amount of acid or base has been added. At this point, there's still going to be excess of the titrant remaining. You're going to have to explain what happens at the equivalence point or near the equivalence point, and then you're going to have to be able to explain what happens beyond the equivalence point when you've gone too far with the thing you're titrating and you've now added excess of that. And then finally, you're going to want to calculate things There are 4 different calculations they require for the AP exam. One is finding the initial pH of the thing in the beaker. That's just whatever. You have to ask yourself what's in the beaker and do the same ice problem we've always done for the first part of the unit. You'll want to find the pH at the halfway point. Halfway means half of the moles in the beaker have been consumed. You'll want to find the pH at the equivalence point. That's when all the moles are consumed stoichiometrically. Moles equals moles. And you'll want to find the pH beyond the equivalence point when you either have excess strong acid or excess strong base, depending on what you're titrating with. Those guys are the keys to what we do here. So that's the intro. There are 5 different types of titrations. This one is going to be video 1. These guys, the weak strongs, are going to be video 2. And the polyprotic is just conceptual. That will be a short video 3. Off we go.